Good day, everyone. Mr. McVeigh here. What I have for you today is the quadratic formula. We're going to solve problems using the quadratic formula. By this point, when you're looking at the quadratic formula, you already know how to factor and solve quadratic equations by factoring, and by completing the square, and by square root. At this point, sometimes factoring an equation or factoring a quadratic equation is not so simple. Maybe there won't be no whole factors, no real number factors, no whole number factors, or no integer factors. And in that case, you need a real easy way to do that. And there's a formula, and we're not going to prove this formula here, but there's a formula that you can use to solve the quadratic formula that'll work every single time for every single quadratic equation you run across. We like to work in standard form, and if you recall, the standard form of a quadratic equation is a times the x term, the x squared term, ax squared, plus the coefficient of b times the x term to the first power, plus some constant c is equal to 0. Now you have to put it in this form. If, for instance, you had an equation x squared minus 3x plus 1 equals 7, this is not in standard form. You have to put this in standard form before you can use the quadratic formula. So in this case, we would have to make this set. We'd want this equation to be equated to 0. So to do that, we have to subtract 7 from both sides. That leaves us with x squared minus 3x. 1 minus 7 is negative 6. 7 minus 7 is 0. And now we can use the quadratic formula because this is in standard form. But what you need to know, let me go to the next page. Ax squared plus bx plus c equals 0. And you should have this memorized by now from your factoring days. To solve this with the quadratic equation, you need to know what the quadratic equation is. And here it is. The quadratic equation is x equals minus b plus and minus, plus or minus, there's two equations here, the square root of b squared minus 4 times a times c, all of this over 2 times a. And this is the quadratic formula. The quadratic formula. And notice the b is the b term in the standard form. The c is the c term in the standard form. And last but not least, the a, and there's two of them in this formula. See, two a's is the a term, or the a coefficient. Coefficient, and constant. B coefficient, there was two of them. One is squared. B coefficients, a coefficient, c coefficients. So the quadratic formula is fairly simple to use. It takes a little bit of work, but all you have to do is when you have your equation in standard form, you take the coefficients and you substitute them in the given locations, do the arithmetic, and you'll get your solutions. Okay. So, for instance, well, before we get to that, there's also some other thing. If you recall, a quadratic equation when we were factoring can have 0 solutions. You can have 1 solution, or it can have 2 solutions. I'm sure you remember that. And if I was to graph that, 0 solutions might be a graph like this, and you notice the parabola never touches the x-axis. That would be 0 solutions or no solutions. 1 solution was where it just touches the axis. And it could be opening up or opening down, but it just touches the axis in one location right there. That's one solution. And two solutions is where it would cross the axis, the x-axis, in two different locations. Okay, so if we look at this term, this is a special term that you see right here underneath the radical. This term, I'm going to put a big cloud around it. This term right here, this b squared minus 4ac, that's called the discriminant. Let me switch pages here. Discriminant. Discriminant. We use a capital D to talk about the discriminant, and that's equal to what was under the radical was b squared minus 4 times a times c. Well, what we use this discriminant for is to tell whether we have 0 solutions, 1 solution, or 2 solutions. Okay, if D, when we substitute the coefficients of the equation that we're considering in, and we get a D equal to 0, then we have 1 solution. If we have a D that comes out greater than 0, we have 2 solutions. And finally, if we get a D that's less than 0, and this is algebra 1, so we're not talking about complex numbers or complex variables or complex equations or complex solutions or imaginary solutions in this particular class. So when we have D equals 0 for our purposes, we have no real solutions. Okay, let us look at an example. Let's now look at an example. The example I'd like to look at is x squared minus 5x minus 14 equals 0. As you can see, this is already in the standard form. And to recall, the standard form is x squared plus bx plus c equals 0. So we know our a is equal to 1. Our b is equal to -5, and our c is equal to -14. And our equation, quadratic equation, that we want to use to find the zeros, remember we're looking for the zeros. Other terms for zeros are where to places where the graph or the parabola crosses the x-axis. The solutions, another term is the roots. In Texas, in the EOC, we usually use the term zeros. So we're finding the zeros, and that's the term you really should be familiar with, but also be aware of the others. So we need to find the zeros where it crosses the x-axis, just like we did when we were factoring. The first thing you probably should do is just look at the discriminant. Remember, the discriminant is b squared minus 4ac. It's part of the equation. Let's write the equation down again. X equals plus and minus. X equals negative b plus and minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Okay. The discriminant, again, as we discussed a few minutes ago, the discriminant is the term here under the radical. Okay. So let's just look at the discriminant. If we check the discriminant, and we can find out really quick if there's a solution or not, or 2 solutions. If there's no solutions, then all we have is to do is just the arithmetic here, and we don't have to do the rest of the equation. And then if we find that there's a solution or 2 solutions, then we can finish the equation and save ourselves a little work. So the discriminant is equal to b squared. In this case, b is -5. So I've got -5 squared minus 4 times 1 times negative 14. And that's 25 and 56, so that's 81. So we know that 81 is greater than 0, so we have two solutions. We have two solutions. And we know it opens up, so if we were to graph this thing somewheres on here, it opens up. Since this is positive, the coefficient A is positive, we know we have two solutions somewheres along the x-axis. So we know that this term under the radical is 81. Okay, so now let's go ahead and finish the equation since we know there's two solutions. So we have x equals negative b, so negative 5 is 5, plus and minus the square root of, we've already done this with our discriminant, so that's 81, so that's the square root of 81 over 2 times a is 1, so that's over 2. So that's equal to 5 plus and minus 9 over 2. And this plus and minus, remember we have two solutions here, so we've got 5 plus 9, so x equals, or x1 equals 5 plus 9 over 2, and our other solution, x2 equals 5 minus 9 over 2, and that happens to be equal to 14 divided by 2 equals 7. And what do we have here? Negative 4 over 2 equals 2. So here's our solutions. So our solutions are x equals, that's negative 2 and 7. So we know that's our answer. And so on this equation, this would cross at negative 2, and this would cross way over here at 7. If you enjoy this and would like to see more videos like this, please subscribe. And like always, have a great day. Mr. McVeigh saying goodbye.